In this third video for Chapter 1, we're going to add supplementary material which discusses inductive arguments and their strength or weakness. And so first let's define our terms. What is an inductive argument and how do we characterize whether it is strong or weak? As we discussed in the last couple of videos, an inductive argument offers a set of premises that support a probable conclusion. So nothing definitive is stated, only that a conclusion is probable or likely. An inductive argument is said to be strong if there is a greater than 50% likelihood of its being true, and it is considered weak if there is less than 50% likelihood of its being true. So if we put this in a chart form on this next blackboard, so the more likely it is that the premises support the conclusion, the stronger the argument is, and the less likely it is that the premises support the conclusion, the weaker the argument is or is considered to be. So let's look at some schemes or some structures that we use to evaluate the strength of an inductive argument. So we're going to use what are called the ARG conditions for evaluating the strength of an inductive argument. First, the premises must be acceptable. That's the A condition. That is that they must be plausible and seem to you to be true. Second, the premises, or each premise, must be relevant to the conclusion, relevant and provide support for the conclusion. And three, the G condition, the premise must provide, the set of premises must provide sufficient grounds for you to reach the conclusion. So let's take a look at applying the ARG conditions in practice to evaluate the strength of an argument, of an inductive argument. So we're going to take a look at this inductive argument, two premises leading to a conclusion. Premise 1, the cows are lying down. Premise 2, almost always when the cows are lying down it rains. Conclusion, it is probably going to rain. So let's analyze it using the ARG conditions. So for the A condition, yes, we can say that the premises are both plausible to the listener. One is observed, and two, the implication that when the cows are lying down it rains is one that we can accept. And for the R condition, yes, both premises are relevant to the conclusion. And three, the set of premises give us grounds to infer the conclusion. A note about likelihood here and the strength of the argument. The argument is as strong as the strength of premise 2, almost always when the cows are lying down it rains. Well, if we had data on that and we found out that 93% of the time when the cows are lying down it rains, then we could conclude with a pretty good certainty that 93% of the time when the cows are lying down it's going to rain. So let's take a look at another inductive argument, several more, to get a better feel for how to analyze them with the ARG criteria and how to determine their strength. So here is a second inductive argument. Almost all Ravens fans live in Maryland or Pennsylvania. Premise 1. Premise 2. Bob lives in Maryland. Conclusion, Bob is a Ravens fan. So let's analyze this for the on the three criteria ARG. So we'll notice that the premises are acceptable. 1 and 2 make sense to us. They are relevant to the conclusion, but the grounds for the conclusion are not there because some information is missing. So what is that missing information? We do not know whether, with any likelihood, whether Bob is in the group of Maryland residents that is a Ravens fan. So if we knew, for instance, that 22% of the Maryland residents are Ravens fans, then we could conclude there's a 22% chance that Bob is a Ravens fan. But we can't conclude any more than that. So this is a inductive argument that would be considered very weak. The probability would be, I don't know, we'd have to have some more information. Let's say 10%, 20%, something like that. So here's a third example of an inductive argument premise. The premise is students who did well in logic classes A, B, and C did well in law school. Conclusion, most students who do well in a logic class will do well in law school. It's a sort of a deceptive argument. It has the form of a valid and strong, or a cogent, and strong inductive argument. But let's see where it breaks down. So yes, the premise is acceptable, and R, it supports the conclusion, but no, the premise C is really not provide or not give grounds for this conclusion. This is actually a hasty generalization. We do not know if this sample is a sufficient sample to make this conclusion. Now, if we knew that in 85% of the logic classes around the country, students who did well in logic did well in law school, then we could say most students who do well in a logic class do well in law school, or there's an 85% likelihood or something like that. But this argument, as stated, is a weak inductive argument because there is not enough information there to make the conclusion, to probably make the conclusion that is being made. Or when we say probably, it's not enough information to know with any high degree of probability, certainly not anywhere near 50%, that this conclusion could be drawn. There are actually several types of inductive arguments, and so far we have only looked at one type of inductive argument, the generalization. The strength of the generalization is dependent on the size and representativeness of the sample. So we've seen that when the sample size is big enough and representative enough, that the inductive argument being made could be strong, and when the size or the representativeness is not there, the inductive argument is weak. These are the types of arguments, the generalizations, that we will spend the most time on, but let's look at the other types to see how we determine their strength. For analogy, so when we have an inductive argument that is of the analogous type, we're saying because a certain type of statement is true, known to be true by everyone, and what we're looking at is very similar to something that we know is true, therefore it's also true. Well, the strength of that will depend on whether we believe that the two cases are similar. Burden of proof, think of courtroom dramas that you've seen. The less plausible the argument, the more burden of proof. So like if there is a lot of evidence saying that this person is likely guilty of murder, and the defense says, no, here's an alternate theory. That alternate theory, if there's a lot of evidence pointing towards this person being the murderer, would have to have a much bigger burden of proof to be convincing. So you need a lot more evidence. Causal reasoning, the likelihood of the causation. We looked at that a little bit when we looked at the high voltage power lines and the incidence of leukemia. We certainly didn't have enough to say that caused a leukemia with just a couple of examples. But if a more in-depth study was done, and we found a much stronger link, then we could, in some cases where the link is more clear, talk about causation. And then hypothetical reasoning, we accept what sounds the most plausible, and reject what is the most puzzling. So it's sort of like a burden of proof kind of situation here. For the most part, though, we will be talking about the generalizations, although we will later on look at some analogies and some causal reasoning when we talk about when we get into the statistics section later. One more thing on the causal reasoning. If we have a high degree of correlation between two occurrences, then that makes it more likely that one of the power lines cause the leukemia or something like that. Doesn't make it a sure thing, but it makes it more likely. And let's talk about one more type of inductive argument that you have some degree of familiarity with already, called abduction. So let's say you have symptoms and you go to the doctor. You say, I have these symptoms, and the doctor listens and thinks, but based on his study of medicine, well, then it's likely that you have either X, Y, or Z as an underlying condition. He or she will ask you some questions and allow him or her to rule out X and to rule out Y, so then the conclusion Z can be made as the most likely cause of the symptoms that you have. So this is done in differential analysis, as they call it, that a doctor will do when you have present with certain conditions. And one more thing about this causal reasoning, high correlation has to be analyzed more carefully, as we'll see later. That may make it more likely that something causes something, or it may not. It depends on what the underlying conditions are, whether the correlation is helpful in determining, or is relevant in determining the likelihood of causation or not. As a general rule, though, the high correlation does not imply the likelihood of causation between two events. In wrapping up this video on inductive reasoning, inductive arguments, I want to point you to an article that talks about the difficulty of analyzing inductive arguments that are made in the media in opinion pieces. And so I'm going to post that link on the Blackboard in just a moment, but the relevant point about this article is that if there can be a strong argument from factual premises, but that doesn't make it one that is thoroughly convincing or a strong argument, because it needs to take into account all relevant facts. And what you find often in opinion pieces is that certain facts are brought forward and other facts are ignored. And so if you present one set of premises, you can get one conclusion, another set of premises, you can get another conclusion. And rarely do you see an article that takes into account all of the premises and gives you a good conclusion based on the entire spectrum of relevant facts in the case. It's hard to find those articles, although they certainly are there, and we will look at some of those articles in subsequent videos. So this concludes this video. Right after I post this link to this site, I want you to read this article. I want you to read. So here's the link. I'll leave it up here for just a couple of seconds, but you can freeze the video at this point and type this link in, and then read the article in preparation for the class that your instructor tells you to read it for. So this concludes this video on inductive arguments.